Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 1. Once again I welcome you everyone. Am I audible? Yes. Am I audible? Can you please confirm? I welcome Vijay, Naresh, Kranti, Akash, Srinivasa Rao, Ammu. Welcome participants, warm welcome. Rohit, Sarathi, Vikash. Am I audible? Am I audible? Can you please confirm? Dear participants, am I audible? Sarathi, Vikash, Chandrasekhar, Parameshwar Rao. Am I audible? Very good evening. Yes. I hope you are getting my voice. So this is Malaipan from Pantech E-Learning Private Limited, and my research area is advanced power electronics, renewable energy, special electrical machines, and electric vehicle power supply design. So these are all my research area. So you can ask your questions related to this area. Right. So about Pantech, Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for power electronics and drives, solar and wind energy related products, fuel cell and electric vehicle designs. And in electronics domain, we have trainer kits for DSP, VLSI, IoT, AI, robotics, and then communication engineering. In addition to that, we have a high-end technical training. So we will help you to create 10 projects, so that will help you a lot in your academic. And our vision is to help 10 million students learn the technology in easy way. So far we have trained about 10 lakh students. Yes. And announcement, you will have a attendance form in live chat. We will provide you at 8:30 p.m. So to get a certificate, so you should have a 25 days attendance. It's mandatory, right? So and in addition to that, you have to pay processing fee as 100 rupees. So that link you will get it at the end of this series. And so before get into the topic, I would like to understand your background. So can you just mention your department name in this chat box? Is it, am I audible? Can you please confirm? So many people are telling very low voice. Am I audible? Is it okay now? Now is it okay? Yeah, now is it okay? Now am I audible? Yeah, mechanical, triple E, ECE. Okay, great. Super, super. Thank you, participants. Thanks for a valuable reply. So many, I mean, you people are mix of all the departments, right? Thank you. Super. See, actually, here I have scheduled this 30 days master class into different domains. Like first, you should understand the basics of electric vehicle, and then one simulation software. And second module is that power converter design, because actually the power electronics is going to play a vital role in this electric vehicle design. So I have scheduled this part. And of course, we need a electric motor. So first we should understand the motor, what is the motor, and then how to control the motors. So I have included that motor part also into this 30 days topic. and the battery management system. So the next topic is the battery management system. In this domain, so I have included the basics of the battery and the parameter estimations of the battery, and BMS design of the battery, and then how we can design our own algorithm to implement the BMS. So these kind of topics I have scheduled in this domain. And of course, finally you can integrate entire EV like a motor, powertronic, and then vehicle, basic vehicle structure, and battery model. So here you can integrate all these things with simulation. Similarly in the hardware, so I ensure that you, after this 30 days, so you can develop your own EV simulation with simulation, EV with MATLAB, as well as in the EV prototype. So definitely I will help you in this topic. So this is my prior agenda. And if you go into the detail, see here, day one. So today we will discuss about what is electric vehicle and how we can calculate our motor power requirements, everything, right? So likewise I have scheduled 30 different topics. So some of the topics will be a projects. For example, if you take a power factor correction design, so this is a one project. So here I will teach you how to design your own power factor correction circuit for the powertronic circuit, like EV charger method, right? Similarly, all the motors has been scheduled, like a DC motor, like a flow 4 quadrant motor control options, BLDC motor control, and FOC motor control for 3-phase induction motor, and PMSM motor control, and SRM motor control, and like that. So these are all the five motor controls. It's equivalent to the motor control projects. Similarly for the battery models, and finally the EV integrations. And here I will give you some hardware insights, how to develop your own EV at whatever the materials available in your local area, right? So like this I have scheduled these topics for you exclusively. So try to engage with the entire 30 days sessions, right? So do you feel this content, this agenda will help you in to develop your EV skill? If you really like this agenda, so please comment in the comment box, I am ready to learn. If you like this 30 days detailed agenda, then you just comment in the comment box, I am ready to learn. I'm just waiting for your reply. Yes, very low voice. Yes, thank you participants. Thank you participants. Great. Power factor correction device is like a StatCom or UPQC. So this power factor correction is like a front end power factor corrections. Yes, thank you participants. So thank you. So let us move to the topic. I will teach you one by one. So here I'm going to give you the complete insights how to start and how to open the MATLAB. So like that I will give you the complete insights. So please try to engage with the entire session, right? So attendance form I will post you in this live chat. So try to engage with the entire session, right? So don't forget to submit your attendance form, because the attendance form is mandatory to get your certificate, right? Right, so this is the detailed 30 days learning path. And we will I will teach you complete topics, right? Right. So now, as we know that electric vehicle, before the electric vehicle, so the conventional vehicles are completely occupied in the transportation industry, right? So the conventional vehicle, what do you mean by conventional vehicle? See, actually, as we know that the conventional fuel powered up the vehicle, so that's called a conventional vehicle, right? So due to the lack of resources, natural resources, now we are into position to change over from conventional vehicle to electric vehicle, right? So here in the case of EV history, so the conventional vehicle was the very first vehicle. So due to the lack of power, conventional fuel, right? But hybrid electric vehicle, again, there is a lot of complexes, and there is a lot of lack of technologies. So now the people has moved to the electric vehicle, right? So this electric vehicle will have a complete electric power. So there is no any conventional power. There is no any conventional or like a petrol or gasoline engine, right? So here, so in this electric vehicle, only the battery is the main source. So if you have a battery power, then the vehicle will run. So if there is no any battery power, the vehicle will not run. But now, so the point is here, as a electrical as a ev engineer, so you should do some research on how to increase the range of the uh, battery, so battery power, as well as that how you can increase the efficiency of the motor, electrical motor, and how you can reduce the thermal issues. Because actually in the ev, so again I will tell you in the next forthcoming slides, so what are all the pros and cons about the ev systems when you move into the industry. So what are all the pros and cons about the ev system, so that I will tell you one by one. So try to engage with the entire sessions, try to engage with the entire session, right? Yes. So the attendance form will be provided in the live chat. So please try to engage with the entire class. Right. So now why we have to move into the ev? Because there is no any I mean there is a lack of natural resources, and second thing is the carbon emission. So that is the biggest challenges I mean all over the world. And third point is that I mean to improve the better climate. So these are all the major points to take a call to move from conventional engine to electrical engine, right? So now you have selected the ev, but what are all the advantages, what are all the disadvantages? So if you take advantages, see here, of course the environmental, Aisha, it's a friendly environmental. And the second is that energy efficiency, because actually in the electrical engine, so you can operate the electrical engine at maximum efficiency like 80 to 90 percentage, 80 to 90%. Whereas if you compare this efficiency with I mean gasoline engine, so that will be a lesser than this electrical power, because there is a lot of movable parts. Here in the electrical engine, there is only one movable part like a rotor. So again the stator is going to be a fixed one, the rotor is going to give you the mechanical force, right? And of course the cost, if you take a cost, actually the market survey shows you the lower maintenance cost. Whereas one more thing is there, after the battery lifetime, so here you have to invest 40 to 60 percentage of the entire total cost of the vehicle, you have to reinvest it. So that is again biggest challenge. And one more challenge is that like charging stations and range of distance coverage, and then temperature. See here, these three major points are there. Just a second. Yeah, so these three major parts, right? So these are all the biggest challenges in the ev market, ev technology. So far I mean rest of india, there is a huge changes in the charging station infrastructure. Whereas in india, I mean recently the ev charging station infra is going to pick up. And recently tata and then reliance signed a mou with the government of india to develop I mean charging station infra. I mean they have initially floated the project in India. I mean Delhi, first project. So they are going to install about 5,000 EV charging stations. I mean in their plan, in their business plan. And similarly the range of distance, so far the vehicle commercial vehicle, whatever the availability in the market, so that vehicle gives you like a 250 is a one part, and then 350 is the second range, and then 425 is the third range. So maximum kilometer will be 425, that is I mean so it's available in Indian market. But what about others? Suppose if you want to go beyond that level, then you have to bear your time. So that again that is a inconvenience for the user. And then finally the third parameter is called a temperature. Here while you use EV technology, so there are some critical parameters are there. In the critical parameters, the very first one is the temperature. So temperature in the battery, temperature in the cabin, and temperature in the motor. So these three temperatures may vary drastically when you use your vehicle, abnormally. For example, if you use your if you put a charger for the EV like abnormal power stage conditions, then definitely there will be a change in the battery temperature. Similarly for the motor, suppose if you are running the motor like off-road conditions, then definitely the motor will get a huge variations in the inside the motor temperature. And again the cabin temperature, of course there is a if there is a malfunctions in the cabin, then of course the temperature may rise. So now you have to manage these three temperatures, right? So again the battery temperature is the biggest challenges in the EV market. So recently, like two wheelers like Okinawa and then Ola electric two wheelers, it's burned due to the battery abnormal charging and then discharging conditions, right? So again still there is a lot of researches are required to reach these limitations, to avoid the limitations. And how we can design our own EV. So very first we should understand the theoretical concepts, and you have to verify the theoretical concepts with the simulation and the hardware validations. So like after the simulations only you can go for the hardware validation. So initially you cannot go for the hardware validation. So this is step 1. So this is step 1, and then step 2, and then step 3. So like this, if you follow the procedure, then you can reduce the production, you can reduce the R&D cost, as well as that you can reduce the research time, and finally you can go for the bulk productions. So now you should validate your EV before get into the productions, right? Yes, voice is very low, right? Let me check up with my yeah ear voice. Just give me a second, I will check. Wired mic, wired mics. Just a second, give me a second, give me a second. Now is it okay? Now am I audible? Can you please confirm? Now is it okay? Now is it okay? Wired, wireless. Now is it okay? I hope now. Just a second, I will. Yes. Am I audible now? Can you comment? Now am I audible? Thank you, participants. Thank you. Now, yes. Now better. Thank you, participants. Thanks for your comment. Yes. Now let's move to the topic. So now, so the point is, if you follow the procedure 1, 2, 3, and then 4, then you can reduce the research time, and then you can reduce the production cost. So now, how you can validate the concept? See here, the solution is that simulation. So the point is, so when you validate your theoretical concepts, like suppose actually I'm going to design the two-wheeler or four-wheeler with so and so specifications. So now you have to verify the design, right? So to verify the design, then you need some platform. So here the simulation is one kind of the validation platform. So and again, to simulate the concepts, you need a lot of simulation. You have a lot of simulation softwares. So here this simulation must be equal to the hardware level, like a system level specifications. So the MATLAB Simulink will help you to reach the exact solutions as the hardware solutions. So if you use the MATLAB software to validate your concept, then that solution will match your hardware fabrications, right? So that's why I have selected MATLAB tool to implement the entire EV, because actually if you go to the Google, like I will tell you one case study. Yes. Yes. So if you just search Google, in all the EVs manufacturer, jobs for, if you search jobs for EV engineer, yeah, if you search this one, so you may get some yeah, see here, if you just go to this link, so there will be a requirements, like what is a job description, something like that. So if you take this if for example, if you analyze the job descriptions, the people will mention the simulation software as a MATLAB model developer. Yeah. So the roles and responsibilities. Here the layout, architecture. Yeah. I'll tell you one by one. Yeah. See here, still software in loop and then hardware in loop. So these are all the Simulink requirements. Yeah, system level solutions. So for entire requirements, so you can verify with the MATLAB Simulink, right? So the people will use in industry also. The people will use as a MATLAB as a simulation software to validate the concepts, as well as like whatever you are developing algorithm in the Simulink, so that same can be downloaded to the hardware also. So that kind of facility the MATLAB will give you. I will tell you how to install and then how to develop a MATLAB and all. So please try to engage with the entire class. Try to engage with the entire class. Right? Yeah. So here this is the MATLAB environment. So here the MATLAB, with this MATLAB, you can develop this kind of software solutions, and you can analyze entire solutions. You can take a results. That result will be equal to the hardware results, right? So that results will be equal to the hardware results, right? So here, let us take this case study. So now we are going to just analyze the system level simulation. What is a system level simulation? For example, if you take this battery model, so now the task is, so this is the EV battery and this is the cabin, right? So now this is the refrigeration system and this is the heater, like so this is the positive temperature coefficient heater. Whenever the temperature rises, so this refrigeration system should supply a cooling air to reduce the temperature. Similarly, whenever the temperature goes beyond, reduces beyond this threshold level, then this heater should taken care about that temperature. So here the temperature should maintain, like, so let us assume that 0 degree to 125 degree. If the temperature goes minus 10 degree, then this heater should reduce this minus 10 degree temperature to reach this 0 level. So here the task is you should maintain the temperature range from 0 to 125. So this is the task. So now the MATLAB simulation will help you to analyze these solutions, and and also the MATLAB will help you to develop this algorithm to implement this same task and in the simulation as well as the hardware. For that purpose only we are using this simulation. And in the MATLAB Simulink model, so we will taken care all the physical parameters like coolant in and then coolant out coefficients and then ambient temperature and then battery cells. So actually if you take a battery cells, there will be a detailed equivalent circuit like RC network will be there. I will teach you those topics in the battery domain, in the battery segment. So try to engage with the entire 30 days class. Right, so like this is the Simulink model. So this is the practical model and this is the Simulink model. We can develop the exact practical model to the Simulink model. So here if you run this simulation, then you can get results. So that result will be exactly equal to the hardware results. So that for that purpose only we are using this MATLAB, right? So again the Mahindra Mahindra group has tested simulation results as well as that hardware results. See here almost both the results are almost equal. And again see here now my objective is to develop a complete EV simulation, right, within this 30 days. So I will help you step by step guidelines to you. Right, so you just invest your 45 minutes on daily basis, definitely you can become a complete EV engineer. Right, if you just listen my class, then definitely you will become a EV engineer. So my intention is to help you and is to guide you to develop the EV model. So actually I have developed the EV model. I completely see here, this is the complete EV model. If you run this EV, then you may get a results. So see here, so here I have developed a complete EV model, right? So I will tell you one by one, so how to integrate and then how to develop step by step results. So actually I took some results, I'll show you later. Yeah. Results. Yes. I will show you later that results also. Just engage with the entire class, right? So this is the step-by-step process. So I will tell you how to integrate this powertronic model, how to connect a motor model, and how to develop our own electric vehicle. So this is here the vehicle subsystem. So I will tell you one by one. So but for that you should attend this 45 minutes class. If you attend this 45 minutes class, then definitely you can reach, you can develop your own algorithm, EV simulations, right? So now, so these are some researchers are available in India, so you can visit their websites to get your career, right? So now let us move to the electric vehicle part. So if you take an electric vehicle, and see here, yes, if you take an electric vehicle, so the very first one is that vehicle structure. So under the vehicle structure, so there is a wheel and then vehicle body and then gear mechanisms, right? So this is the very basic components. And after that, the electrical part. So under the electrical part, battery module, motor module, and then power control unit. So the power control unit nothing but it's a powertronic circuit. Right, so the battery and then motor. See here, you have a question like motor, right? So the motor is helping to convert electrical power into the mechanical power. So now the electric vehicle is going to run this it's running. Sometime it requires a zero speed, sometime it requires average speed and then maximum speed, right? So here people will call it as a variable speed applications. The electric vehicle nothing but it's a variable speed applications. So similarly you have a constant speed applications also there, like a conveyor or a lift and other robotic applications and constant speed applications. So the electric vehicle comes under the variable speed applications. So now the motor should run at a variable speed range. When whatever the battery sources are available, the motor should run at a variable speed. So to help to run the motor at variable speed, the power electronic circuit is required to reach the desired speed, right? So that's why we are calling it as a power control unit. So power control unit. And again, the third model is that other essential components, like other than this basic elements, right? Like I mean what, a cabin, I mean other infotainment systems, and then I mean what, a wiper module, and then other lifting systems and all. So now if you completely understand these two models, if you completely understand, see if you completely understand this two model, then you can develop your own EV. So that is my intention. So first you should know how to select a vehicle body, and then how to select a vehicle gear and then wheel, and how to select a motor, how to select a battery, and how to develop a power control unit, and then how to design our own OBC model. If you know these things, then definitely you can enter the EV segment. You can kickstart your career in the EV. So nowadays, suppose if you are being a mechanical or automobile engineer, so you may very well about this area, but here you may get some lagging, right? So you don't worry, I will help you to clear all your doubts. So whatever you have a doubt, I will here, you can post your questions, you can post your queries in this chat box, and after this live, you can post your queries in this video comment box. I will answer your all the questions. So try to engage with the entire sessions, right? So now if you take a EV parts, again if you are discretizing the furthermore EV model, so vehicle body and motor and inverter model. So and then the inverter needs a battery, like a power source. So the battery pack is available, and after that OBC model, so like a onboard charger model. So this charger model will receive a power from the charging station. So now the power flow is from the charging stations to OBC model, and then OBC to battery, and then battery to inverter, and inverter to motor, and finally that motor power converted transferred to the wheel, right? So due to that mechanism, the vehicle will get forward, right? So this is the power flow. So till here we will have a electrical power, till we will have a electrical power, and after that here we will convert a mechanical power. So here, for example, if you take a inverter model, so what is the purpose of inverter? Can you just tell me in the comment box, what is the purpose of inverter? Can you just tell me what is the purpose of the, can you just tell me what is the purpose of inverter? Can you just tell me what is the purpose of inverter? I'm just waiting for your comment. Yes, exactly, participants. So here, see, based on the, I mean, it depends the type of the motor, So we will use sometime it as a converter, and then sometimes we will use as a inverter. So here the battery power is a fixed one. So we need a variable power supply to change the motor speed. So now we need a inverter model. Right? So similarly, the battery bank. So here there is a lot of types of batteries are available. So I will tell you how to design the battery, and then how to calculate the battery for our motor power requirement. Everything just to try to engage with the entire session. And if you take a block diagram, see, the vehicle body will receive a motor power from the motor, and the motor will get a controlled power supply. So the motor will get a controlled power supply from the motor controller, or generally we can call it as a inverter. Right? So here the inverter will get a power, that is a maximum full power from the battery. Right? So on an average, the battery power will be like a 300 voltage, and some I mean small vehicles will have a like a 48 voltage, 72 voltage, something like that. And here one more control signals are there called a drive signal. right? So the driver input, because the driver is going to accelerate for some time and decelerate for instance, right? So the controller here, the control signal generator, see here generally we will use any one of the microcontroller, right? So any one of the microcontroller. So the microcontroller will receive a driver signal input. So the microcontroller will receive a driver signal input, and it will calculate the control signal. So generally in the electrical power electronic domain, the people will call it as a pulse width modulation. See, generally called P pulse width modulation. So the microcontroller will receive a control signal from the driver, and it will generate a PWM to change the motor speed. So this PWM may vary from 0 to 100%. 0 to 100%. Right? Right? So now let us move to this one. So let us try to understand the vehicle basics. So how we can attendance form not yet provided. Just a second. The attendance form will be provided at 8:45 p.m. Just wait, please wait. We will give you the attendance form. Just wait. Right. So now let us try to understand how to calculate the motor. See here from this block diagram, you can design the vehicle body, right? So here to move the vehicle, so you must know motor, right? So how we can calculate the motor? So this is the very first step. If you selected the motor, then you can go for the other part. Right? You can go for the other part. So now we are going to discuss about how to design our own electric vehicle. For that, you must know what is the vehicle dynamics. I will tell you one by one. Try to engage with the entire session. See here, if you take a vehicle, see here, if you keep the vehicle at a standstill position, so there will be two forces. One is called the push force. Whenever the push force is higher than the friction force, then the vehicle will be in the forward bias or forward directions. Whenever the push force is less than the friction force, then the vehicle will not move into the forward directions. So now you should calculate how much force is required to overcome the friction force. So to understand these concepts, you must know what is the friction force and what are all its types. See here, the friction force is nothing but, so due to its vehicle and then due to its gravitational force, the friction force may rise. Right? So here again one more force is called like aerodynamic drag force. When your vehicle is in the forward directions, so due to the aerodynamic design, so the high pressure area may create in the opposite directions of the vehicle. So now you should overcome these forces also. So to calculate, to overcome these opposite forces, so first you should calculate the total tractive forces. So now the motor, which are going to place the motor in the vehicle, right? So the motor power, that is the motor power in the range of kilowatt. Right? So this motor power, kilowatt range of the power, should have a calculations of the total tractive force into the velocity of the vehicle. See, for example, assume that I am going to run my vehicle at 40 km per hour. So now you should calculate some forces like Newton meter and multiplied by this velocity. Then you can arrive this kilowatt. Right? So like that we have to calculate the motor power. I will share you the calculations. So try to engage with the entire class. So now let us try to understand the total tractive forces. See here, the total tractive force is nothing but a very first one is that rolling resistance force. Very first one is that rolling resistance force, and the second one is that aerodynamic drag force, right? And then hill climbing force and acceleration force. And under the acceleration, so due to the gear and then the power needs to be transferred, right? So in that case, so there will be a linear acceleration and then angular acceleration. So two forces will be there in the acceleration force. So now let us try to understand what is the rolling resistance, what is aerodynamic drag. So the rolling resistance is nothing but it's opposite force. Simply just to keep in your mind, it's opposite force. So that force can be calculated with the help of this formula, that is mu rr into m into g. So m is nothing but it's a mass of the vehicle, and g is nothing but the gravitational acceleration constant, right? So again here it's 9.81. And mass, again we are going to decide whether you need a half car, two-wheeler or four-wheeler. If you are going for the four-wheeler, and then how much how much weight it can handle, right? So that the designer should select this value. And again the rolling resistance constant. So this is a it's a mu r, it's a constant. So that constant has some values. Actually, that's derivations. There is a lot of derivations are there. So we are not going into that detail about the derivations. You just keep in this mind. So some typical value you can select it. Some typical value you can select it. So that typical value depends the tire material and then structure, temperature, pressure available inside the tire as well as the outside the tire, temperature tire. And then tread geometry like road roughness, material, and liquids available, and as well as that absence on the road. So these all the factors are going to decide this constant value. So typically we can select this kind of values. For example, wheels on the rail. So nothing but it's a if you take a train, so there is no absolutely there is a low rolling resistance force, because the flat surface and then everything is perfectly designed. So there we are having very less rolling resistance value, because if this value is high, then we need a more motor power. If you keep this value and low, then we need a very less motor power. If you keep a very less motor power, then of course you may require the motor will consume very less power from the battery. If you consume very less power from the battery, then you can increase the vehicle distance. All these parameters are the interlinked one. Right? And similarly, the next is that aerodynamic drag force. So here, when you drive a vehicle, so there will be a two kind of pressure may create. So generally, if it won't create in the standstill position. So this kind of forces will be generated while it is in the vehicle in the running conditions. See here in the vehicle front side, there will be a high pressure area. So the vehicle front side, there will be a high pressure area. Similarly, the low pressure area. Suppose if there is no any high pressure, then the motor requirement may be very less. So now you are into overcome these two forces. See, actually in your vehicle, generally the rear spoiler will be used, right? So that rear spoiler component is used to reduce this low pressure. Generally, the MPV vehicles will have that kind of MPV, and then hatchback vehicles will have that rear spoiler. If you keep this rear spoiler, then you can avoid or you can reduce the low pressure area, because that dynamically that pressure will be removed from its with the help of that design. Of course, the high pressure area, suppose if you are designing your vehicle to avoid this one, then you can avoid this pressure. So you can avoid this high pressure. So now, of course, whatever it may be, due to the designs of the vehicle, then we can avoid the we can improve the vehicle performance. So this force is calculated with the help of this formula. So all these formula, again, this is the air density is constant, frontal area. So now we can calculate the frontal area like width and height and then breadth. And similarly the drag coefficient. So here each and every design will have a drag coefficient, right? Again, we can select this value, and absolutely of course the velocity of the vehicle we are going to decide the value decide this parameter, like 40 km per hour or 100 km per hour or 200 km per hour, right? So this parameters we are going to design it. So with the help of this formula, we can calculate our own vehicle. So similarly, so some typical values. See here, for this value, like if you take this airfoil, it's very less. Drag coefficient. So again, here also we have to keep very less value as a drag coefficient to improve the vehicle performance. Some typical values are used. You can just take a note. You can apply this one. And hill climbing force. See, generally, if your vehicle is the upgradient path, so there will be some angle, right? So this angle needs to be calculated. So generally, m into g into sine theta. So here the theta can be calculated, and then m and then g is the again these are the deciding parameters. But for the safest design, see, for example, the architect or civil engineer will use this safest design parameters to construct like a bridges or something like that. On the road design. So up to that is the on-road vehicles or off-road. For off-road vehicles, the people will use up to 45 degree. The theta can be reached maximum 45 degree. If the vehicle keeps again more than 45 degree, then there is a chance to slippage, right? And so now you have a calculations. See, for example, if you calculate the rolling resistance force, aerodynamic drag force, hill climbing force, and then linear acceleration and then angular acceleration. So if you calculate all the forces and then multiply it by the velocity, then you may get a total motor power. Right? So if you take this formula, yeah. So as we know that rolling resistance and then aerodynamic drag force and then hill climbing force. So here the linear acceleration and then angular acceleration. Generally in the EV electric vehicle system, so you can develop without gear also, because the electric motor or electrical engine can give you that flexibility. So here the motor will have a direct drive systems. You can take a 2 motor system or single motor system or 4-wheel drive also you can use it, so that we can avoid the gear system. If you avoid the gear system, then we can avoid this angular acceleration things. So straight away we can go for the linear acceleration, like mass into m into a. That is the acceleration constant, and mass, that is the weight, mass of the vehicle, right? And if you want to use the gear system, simply just take up 5%, that is like a thumb rule, 5% of the linear acceleration. So 5% of the linear acceleration, then you can calculate the angular acceleration. For instance, I am just taking some value, like these are also some data, mass, weight, and then height, like a 1000 kg vehicle, and width and then height is about 1 meter, 1.5 meter. Yes. Attendance form. Yes. Voice view is blocking. Okay. Okay, right. I will change the position. If you have any questions, you please comment. Attendance link is working fine, properly working fine. So just click once again. Yeah, so it's perfectly working, so you don't worry. You just check once again. If you have any questions, you please. Yes. Yeah, PDF will be available. PDF will be available in the internship link. Check it. Notes, PDF. Yeah, we will. All the PDF and then project files, everything is available in the internship portal. You can use it for your applications. You just take a note about these calculations. Just to take a note about this WhatsApp group. After this live, I will share you in the email. So try to engage with our entire email system, right? Entire email systems. Yeah. If you have any questions, you please comment. MATLAB, yeah, of course. Actually, I will cover all the parts of the MATLAB. So try to engage with the, because actually without basics of the EV, we cannot move into the electric vehicle system. So I will keep on introduce the MATLAB. You don't worry. Definitely, I will introduce the EV. MATLAB systems. So now let's come to the calculations. See here, as we know, we are just calculating, we are considering rolling resistance and the aerodynamic drag force. So I have avoided the hill climbing force and then linear, acceleration force, right? Just I am going to take two acceleration forces, sorry, two forces. One is the rolling resistance force and then aerodynamic drag force. So if you apply this one, then you may get a calculations about 2.5 kilowatt. So that is a 2.5 kilowatt motor. So I have a Excel calculator. I will show you the calculator. Yeah. Yes. See here, we have used the same calculations. You may reach the value about 2.5 kilowatt. So now if you change the speed, instead of 40 kilometer to 50, or maybe increased. So now you have to motor is required. For the 40 kilometer per hour, like a 1000 kilogram weight and then a 1 meter and then 1.5 meter dimensions vehicle may require 2.5 kilowatt motor. 2.5 kilowatt motor. So this Excel calculator will be available in the LMS portal. So try to use it. But my recommendation for you everyone, so please prepare this Excel calculator. So it's like just simple formula. Simple formula, whatever we used. See here, this two formula, right? Mu RR M into G. So G 9.81 and then M is the weight of the vehicle, and then mu RR we have to select like some from the typical value. All right. So from this calculator, you just take, yeah. So mu RR like a 0.02. So this is the constant value, and similarly the drag coefficient you can select it, and the 9.8. So remaining things you just consider, you just use the calculator, just arithmetic calculations to reach this calculator. So now we have calculated the motor power is about 2.5 kilowatt. So I will give you the assignments, like you just prepare this Excel calculator and share this Excel calculator in the FB group. I will share you the FB group link here. Those who are all not available, so just share this one. Facebook. Yeah. So just prepare this assignment and share the assignment in our yeah. Yes, I have given the FB group link. You just post your assignments in the FB group link. Just post in the FB group link, right? Just post in the FB group link. So I have given the FB group. Here I have given the FB group. So I will give you the FB group in the WhatsApp link, WhatsApp group, and other things. So try to engage with the entire communications. So here I'm getting very slow. right? So I hope you got the point how to calculate and how to calculate your motor, right? Mass and weight both are different. Yeah, weight is the mass. M. Weight is the mass. M. Assignment, you have to prepare this Excel calculator and then post the Excel calculator in the FB group. FB group. If you have any questions about this one, so please post your questions. Attendance form is the top of the chat, so please check. If you have a FB group, then it will help you to improve your social profile. So try to create a FB account and then post in the group. So those who are all not having FB group, so please prepare the calculator and pay. So while you select a weight, so you have to consider the rider weights also. You have to consider the rider weights also. Why overheating can be occur EV no cool system. See, actually, there is no cooling system. Is not a perfect. Actually, everyone are implementing the cooling system, like a air forced cooling system and then oil forced cooling system are used for battery as well as that motor. So for the two system things that we are using. I don't have laptop. What would I do? See, actually, you can attend the class and then you can score the certificate. You can attend the class and then you explain the units. See, just these are the basic models just to have it. So unit like a mass, of course, you should call it as a weight, like a kilogram, and then meter, something like that. Yes, motor power. It's a motor power or a motor power at wheel. So this is the motor power requirement. So internship, I will tell you one by one. You have to pay internship. I will come to the point. So the next, let us check. See now from this Excel calculator, you can understand why increase the speed, that is the speed ratings. Instead of 40 kilometer, if you increase to 50 kilometer, then the motor power may be highest one, right? So here, so this is the thing. If you increase the motor power, so you need a mechanical motor power requirement at a higher value, right? So this is the things. So keep on, it's getting increased, right? So this is the motor power requirement. While running the class, sometimes video buffers. Okay, right. Tomorrow I will try to adjust the issue. Excel sheet, you can download it from the internship portal. Excel sheet, you can download it from the internship portal. Battery management system is included in this one. Which motor is used in electric vehicles? I will tell you. So try to engage with the entire class. I will tell you, try to engage with the entire class. So now tomorrow I will take a MATLAB sessions. So how to open the MATLAB and then how to develop a MATLAB model, everything. So try to engage with the entire class. Try to engage with the entire class, right? So this is the typical value I have selected. I will show you some MATLAB demo. So try to engage with the entire class. So now time is over. So tomorrow I will take and then I will show you the complete information about the MATLAB. So we can start the MATLAB from tomorrow. Are you ready to learn the MATLAB? Yes. For inverter design EV, which one is preferred, power MOSFET or IGBT? Yeah, Mr. Durga Prasad, we will use a SIC MOSFETs. SIC MOSFETs. Yes. So tomorrow we will, tomorrow we will discuss about the MATLAB. So I will show you the MATLAB basic example, and then driving cycle scenario, and then vehicle model, everything I will tell you in the tomorrow class, right? And again, so the how to select a motor, and these parameters also there. So tomorrow we will discuss in detail about these topics. Tomorrow class we will discuss in detail about these topics, right? So I will tell you one by one. I will tell you one by one why it is torque, maximum torque is required, why the maximum power is required, what is the battery capacity, everything we will discuss one by one. So try to engage with the entire class, right? Try to engage with the entire class. Why don't you consider the linear acceleration force and the hill climbing force? Yeah, Mr. Baba Shaheb, see, actually for understanding purpose, so those who are all for the new people, for understanding purpose only, I have used these calculations. Whereas in the day 5 class, we will cover all the calculations. The day 4 class, we will cover all the calculations. What is the role of mechanical engineer in this EV design? Mr. Prajit, see, actually now you are into position to acquire the powertronic concepts. If you acquire the powertronic concepts, then definitely you can shine in the EV domain. Yes. So now the internship, actually 1 month internship is available. 1 month internship is available. So here we will give you the internship certificate. So it's a soft copy, not soft copy. Key certificate will be provided, and then you can access all the 30 days classes, and you can download the MATLAB project files. You can access the 60 days content from the login, and I will give you the WhatsApp group, VIP groups. I will give you the complete results, right? And see here the internship link. You just click this description, video description. You will have a comment. I mean, yes, I will show you. So just go to the this video description. This video description. So it's pantechelearning. So it's pantechelearning. So here you may get a, yes, this is the link. This is the link. You can get a internship option, and you can apply a coupon code. Just fill your name and then fill your email ID, and here just give complete name, complete your name, right? Don't skip your name, and apply the coupon code welcome EV. Just apply the coupon code welcome EV. So now you may get a 598 rupees, right? And after that you just fill the name and then get it. So after the payment you will get a email from our LMS system. So just log into the LMS portal. So those who are all registered, we will give you the access. Those who are all registered, we will give you the access. So here electric vehicle, yeah, electric vehicle master class will be there. So you can check all the classes. Yeah, see here, so below the video, so there will be a downloadable part. So how to download the MATLAB files, and how to see here the PPT and simulation files, and then Excel calculators. So everything will be there. So Excel calculators, everything will be there. So you can use it for your application. So like that, I mean, complete 30-day topics are there. And in addition to that, we will give you the bonus content like renewable, EV with renewable system. EV with renewable system. So that project also we have included into this project, into this course. So you can use it for your research, academic purpose. Now you can ask your questions. I will try to give you the answers. Now you can ask your questions. I will try to give you the answers. If you feel this class give you some insights about the electric vehicle introductions, you can share your view feedback. I will try to include into the next class. Yes, accept my request in the FB. Definitely after this live I will do that job. Where is the attendance link? Mr. Yeah, Day1, in the top of the chat there is attendance. Then life of battery, please. Actually, as of now, the battery battery period is 7 years. Battery period is 7 years. It's perfectly tested. WhatsApp group fill. Yes, I will give you the new WhatsApp group. So please try to engage with the entire communications. So in the email, I will give you the new WhatsApp group link. Why not coolant for thermal cooling is using for the liquid nitrogen? Nunna Venkatesh. So let me check up and then answer your questions. Thank you, Mr. Chandrasekhar. Thank you, Mr. Vishnu. Thank you, Mr. Shonu. Srinivas Kalyan, thank you. Yeah, Mohammed, thank you. Sagar Bori, certificate fees. See, actually, if you are into the internship model, so you will get an internship certificate and then participation certificate. Excel sheet calculator. See, actually, you have to develop a calculator to implement all the specifications. So just to take a formula. What are all the formula for calculating the total tractive forces? Just model one Excel calculator. MATLAB software I will share you in the WhatsApp group as well as the email. MATLAB downloadable link I will share you in the email as well as the WhatsApp group. Scope of the mechanical engineer. See, actually, if you are being a mechanical engineer, you can easily learn the electric vehicle concepts. 100% it is useful for the electrical engineering students. Mr. Yuvraj, after 30 days completion, you will get a participation certificate. Job opportunities, we will give you the job alerts in the WhatsApp group. MATLAB Simulink is the simulation software which we are going to use it in the for the 30 days class. Hybrid electric vehicle is a partial vehicle. So full electric vehicle is nothing but the full electric vehicles. 100 rupees is the certificate fee. Mr. Abhishek, it's a MATLAB Simulink. What motors do we use, axial or radial? See, actually here as of now we are using the axial motors. In the EV domain for the ECE engineer, so you have a option. You have an option for the BMS development and algorithm development, like embedded. You can become an embedded engineer because here the microcontroller is going to play a vital role. Yeah, thank you, Mr. Manikanta. Thank you. The power consumption. See, again here, this motor power requirement is the power consumption by the motor. Again, from the battery, that is a different scenario. So, in the battery segment, we will discuss about those things. Mr. Abhishek, I answered your questions. MATLAB Simulink is the software. Biswajit, there are a few type of motors are there. So I will cover in the forthcoming classes. So basically it will be a PMDC, BLDC, PMSM, and then interior permanent magnet DC motor, permanent magnet synchronous motor, and then SRM motor. Yeah, Mr. Sunani, you have to prepare this Excel calculator. You have to prepare this Excel calculator. Yes. Thank you, participants. Thank you for your valuable time. And if you feel this class give you some idea about the EV, so you can share your video feedback. You can share your feedback to this live chat as well as this video comment box. What is LMS portal? LMS portal is an internship portal. So in the internship portal, you can watch all 30-day class. This is the LMS portal. This is the LMS portal. So here you can watch all the 30-day classes, and here no need to worry about the attendance form, because actually whenever you watch the video, your attendance will get marked. Whenever you watch the video, your attendance will get marked. We have to pay for the internship. No, the 598 rupees is includes everything. 598 rupees includes everything. So total fee is only 598. If you are paid internship, then you may get a complete things. Facebook link I will share you in the WhatsApp group. Now it's not possible. I will share in the WhatsApp group, FB group link. ANSYS is not included. Actually, in the next series, like motor control design, we are going to motor design masterclass. We are going to introduce later. So in that one, we will include the ANSYS. Thank you, participants. Thanks for your valuable time. And if you have any feedback, so you can share, and then you can take my WhatsApp number. So you can post your questions also. So this is my WhatsApp number. So just take my number. If you have any questions, you can ask your questions, and then you can call me during the office hours. So this is my WhatsApp number. You can call me. You can post your questions. Yeah, Mr. Puneet, you can have a better choice. You can convert. Yeah, Mr. Vamsi Raj, after this live, we will share you the link. Mr. Praveen Kumar Reddy, how can I pay 100 rupees? After this 30-day series, you will get a link. Thank you, participants. Thanks for your valuable time. And we will meet you in the next class. Thank you. Thank you once again. So the internship link I will share you. So this is the internship link, the internship registration link. So internship registration link is there, so you can use it. Thank you, participants. Thanks for your valuable time.